required to prove if a is an odd integer, then a squared plus 3a plus 5 is also odd. Okay, proof. Here it is. Let's suppose a is odd. And it's an odd integer. A is 2n plus 1, where n is some integer, and this is the definition of an odd number. So a squared plus 3a plus 5 equals, subbing in 2n plus 1 wherever we see a, so there and there will be replaced with 2n plus 1. We get 2n plus 1 all squared, 3 outside of 2n plus 1, plus 5. This in turn equals, once we expand a plus b all squared, the pattern, we get a squared plus 2ab plus b squared. We're familiar with that. So a squared, in other words the first term squared, 2n all squared is 4n squared, plus 4n, because that's 2n times 1, and double that is 4n. 1 squared is 1. Then the second term expanded, 3 times 2n is 6n, plus 3 times 1 is 3, plus 5. Now, tidying this up, we have some like terms, 6n, 4n. Did you hear the horse? Did you hear the horse? I heard a horse just down the road. I wonder if you heard that on the video. 3 and 5 is 8, and we want a 1 because we're trying to show that the expression is odd. How at that time did you hear the horse? Now what we do is we leave the 1 outside. You may have seen this already, because the form up here has a 1. You might be starting to get used to this. We need a 2 outside of something, so let's take a factor of 2 outside of 2n squared plus 5n plus 4, and we have the plus 1 still. This equals 2b plus 1, where b equals that 2n squared plus 5n plus 4. Okay, which is basically just an integer. Don't write this on your proofs, but this is for the sake of learning. It's a bit too bold to write on a formal proof. It'll shock people. Okay, but seriously, we've just replaced that. That's an integer anyhow, and this is consistent with the definition of an odd number. Not the best setting out, Mr. Herbert. You should be able to make this a bit more. The annotations are fine, but you'll be able to keep this tidier on your page. Definition of an odd number. We have now that is equal to, remember that is equal to the a squared plus 3a plus 5 that we're talking about in this proof. Thus, what we're trying to find, a squared plus 3a plus 5, is indeed odd. We've proven what we set out to prove, Q, E, D, proper 1. There we go.